Welcome to another deep dive. Today, we're going to be tackling the many worlds interpretation of quantum mechanics.
Oh, okay.
Yeah, the one that says every quantum decision basically creates a whole new universe.
Oh, wow. Okay.
So yeah, buckle up because this one gets weird.
Weird is putting it mildly. It's definitely a fascinating idea.
Yeah,
But I think as dive into this source material that you have,
right.
you'll find it's not without its critics.
It's not without its critics, exactly. We're diving into an article that really takes a hard look at MWI,
Okay.
and it really scrutinizes it. The article actually compares it to like invoking invisible fairies to explain like the weather.
Oh, wow.
It argues that relying on all these unobservable universes might make MWI scientifically shaky.
Yeah, it's a compelling point. But let's back up for a second.
Okay.
The basic premise of MWI is that the wave function, which describes the probabilities of different outcomes in quantum mechanics, is taken as a literal description of reality.
Okay.
So it's not just a mathematical tool, it's real.
So instead of saying a particle is in a blurry superposition of states, MWI is saying each possibility is actually playing out in its own separate universe.
Exactly. And the key here is that every quantum measurement, every interaction, causes this branching of reality.
Okay.
You remember Schrodinger's cat?
Oh,
The
yeah.
thought experiment.
Oh, poor cat.
Yeah, with a cat in the box.
Both alive and dead until you open the box.
Well, in MWI, there's no such thing as a cat in superposition.
Okay.
Instead, the act of opening the box splits the universe in two.
Gotcha.
In one, you find a very relieved cat, and in the other, well, not so much.
Okay, so every possibility becomes a reality.
Yeah.
That's mind-blowing. But it raises a huge question. What happens to probability?
Right.
I mean, if every outcome occurs, how can we say one is more likely than another? The article really hammers on this, doesn't it?
It does, and for good reason. This is one of the biggest criticisms of MWI. If everything happens, what does it even mean for something to be probable?
Yeah, it's like saying if I flip a coin, it lands on both heads and tails.
Right.
But heads is still more likely.
Exactly.
It doesn't make sense.
You're getting to the heart of the problem. Classical probability is about one outcome per event, but MWI says all outcomes occur.
Right.
They seem fundamentally incompatible.
So how do proponents of MWI try to get around this? I remember the article mentioned something about counting branches in the multiverse.
Yeah, that was one of the early attempts.
Okay.
The idea was, if there are more branches where the cat is live,
Right.
then alive is the more probable outcome.
Seems logical enough, right? More branches equal higher probability.
The problem is that the number of branches is both infinite and dependent on how you choose to define a branch.
Okay.
It gets very arbitrary very quickly.
Yeah.
Plus, a single measurement doesn't guarantee an even split of outcomes. It's like assuming every coin flip results in exactly 50-50 heads and tails.
Okay, so just counting branches doesn't cut it. Then the article gets into this thing called decoherence,
Right.
which, if I'm being honest, was a bit over my head.
Okay.
It talks about the preferred basis problem, which sounds even more complicated.
Well, decoherence is a crucial piece of the puzzle, so let's break it down.
Okay.
Think of it like this. Imagine a drop of ink spreading in a glass of water.
Okay.
Initially, it's a concentrated blob.
All right.
But as it interacts with the water molecules, it disperses and eventually becomes indistinguishable from the rest of the water.
Okay, I'm seeing the analogy here. So the ink is like a quantum system and the water is the environment.
Precisely. Decoherence describes how a quantum system, like our cat in the box, interacts with its environment. This interaction causes the system to seemingly choose a definite state. It's like the ink drop losing its distinct identity and becoming part of the water.
But if all these branches of reality exist, how does the environment choose which outcome becomes like the real one?
Right.
The one that we observe. That's where the preferred basis problem comes in, right?
You got it.
Okay.
The preferred basis problem asks, what determines the basis upon which the wave function collapses?
Right.
Making one outcome observable in our reality.
Yeah.
If every outcome has its own reality, as MWI suggests, then why do we only see one?
That's a really good question.
Yeah.
So decoherence, while important, doesn't really solve the problem.
Right.
It just kind of pushes the question back a step.
Exactly. If the branches aren't fundamental but emerge from some deeper process,
Right.
then how do we even assign probabilities to them?
Yeah.
It seems we're back to square one with the probability puzzle.
Right.
The article highlights that this conundrum has driven physicists to come up with all sorts of explanations.
Okay, so what are some of those explanations? What did physicists come up with to try to resolve this? Tell me more.
Well, one approach that you'll find discussed in your source material is the idea of using decision theory to try and make sense of probability in MWI.
Okay.
Physicists like David Wallace and David Deutsch have, explored this idea.
Decision theory. So like how we make choices. What does that have to do with quantum mechanics and multiple universes?
Yeah, it's a bit of a head scratcher at first, I know.
Right.
But the idea is that if you were a rational agent living in an MWI universe,
Okay.
you would act as if the Born rule, the rule that tells us the probability of measuring different quantum states, were true.
But wouldn't that be assuming the very thing we're trying to explain?
Right.
I mean, isn't that just saying, well, we see probabilities in our measurements,
Uh-huh.
so let's just assume they work the same way in the multiverse?
That's a valid criticism, and the article brings it up too.
Okay.
In fact, it cites philosopher John Norton,
Okay.
who argues that in a deterministic system like MWI, you can't derive probability unless you already assume it somewhere in your premises.
Right.
It's a bit like trying to pull yourself up by your bootstraps.
So decision theory doesn't really solve the problem.
Right.
It feels more like a workaround,
Uh-huh.
kind of like saying, well, it works in practice, so let's not worry too much about the theory.
Right, and that leads us to some broader philosophical objections to MWI that the article explores.
Okay.
It brings up the idea that extraordinary claims require extraordinary evidence.
That makes sense. I mean, we're talking about an infinite number of universes constantly branching off.
Yeah.
It's a huge claim,
Right.
and it would require some pretty strong evidence to back it up.
And that's precisely the problem.
Yeah.
Unlike other revolutionary theories in physics like relativity or quantum mechanics itself,
Right.
MWI doesn't have that kind of solid empirical evidence behind it.
Okay.
We only ever observe one outcome, one reality.
Right.
So from that perspective, wouldn't it be simpler to just assume a single universe?
Occam's razor and all that, right?
Exactly.
The simplest explanation is usually the best.
Uh-huh.
You know, the source material uses a really great phrase to describe this whole issue.
Yeah.
It talks about the metaphysical baggage that comes along with MWI.
Ah, yes. The metaphysical baggage.
Yeah.
It's a very evocative way of putting it.
It is.
Essentially, the article is pointing out that MWI forces us to accept a whole host of unobservable entities and untestable assumptions.
Okay.
We're not just talking about parallel universes, but also about the idea of all these different versions of ourselves existing across the multiverse.
Wait, different versions of me?
Yeah.
There's a universe out there where I'm a rock star. I knew it.
Well, that's one of the implications, yes.
Okay.
But it gets even more complicated.
Okay.
The article highlights how some attempts to explain probability within MWI introduce even more untestable assumptions.
Right.
Like the idea that all these different yous are somehow part of a single rational agent,
Okay.
making decisions across the multiverse.
Whoa.
It's a lot to swallow.
It definitely adds like a whole other layer of mind-boggling complexity to an already mind-boggling concept.
Right.
So we've got these scientific challenges like the probability puzzle, and then we have these philosophical issues about the sheer scope and lack of evidence for the multiverse.
Yeah.
It seems like MWI is running into a lot of roadblocks.
Yeah.
What's the alternative? Is there another way of looking at things?
There is, and the article presents a rather thought-provoking one.
Okay.
Instead of trying to force the universe into this deterministic MWI framework where everything is predetermined by the wave function,
Okay.
what if we just accept that maybe at its core, the universe is fundamentally probabilistic?
You're saying, what if instead of inventing all these extra universes to explain away randomness, we just accept that randomness is a fundamental feature of reality?
Precisely. Maybe instead of imposing our own theoretical frameworks on the universe, we should listen to what nature seems to be telling us.
Okay.
That there's an inherent randomness at play, and that the probabilities we observe in quantum mechanics reflect this fundamental property of the universe.
That's a pretty radical shift in perspective.
Yeah.
Instead of trying to fit everything into like a neat and tidy deterministic model,
Uh-huh.
we embrace the chaos, the unpredictability.
Yeah.
I like it.
It's certainly a more humble approach, I think.
Yeah.
It acknowledges the limits of our knowledge and accepts that some things might simply be beyond our ability to predict or fully understand.
Right.
The article argues that this perspective is more consistent with what we actually observe.
Okay.
After all, we only ever see one outcome,
Right.
and those outcomes seem inherently probabilistic.
So where does this leave us? We've delved into this fascinating yet problematic idea of the many worlds interpretation with all its mind-bending possibilities and conceptual hurdles.
Right.
We've seen how it struggles to explain probability and how it requires us to accept a whole lot of untestable assumptions.
Hmm.
But we've also explored an alternative perspective, the idea that maybe the universe just is fundamentally random.
And this exploration has brought us face to face with some pretty profound questions about the nature of reality,
Yeah,
but the limits of scientific inquiry, and our own place within this vast cosmic scheme of things.
right.
It's a reminder that even our most cherished scientific theories are constantly evolving as we learn more about the universe.
I think you've hit the nail on the head. It's all about that constant questioning and exploration. But before we wrap things up completely, I want to leave our listener with one final thought-provoking question. If you were a physicist, like standing at the edge of the unknown, facing this choice between the mind-boggling complexity of many worlds and the maybe less glamorous but more straightforward acceptance of fundamental randomness, which path would you choose, and what implications would your choice have for how we understand the universe and our place in it?
That's the million-dollar question, isn't it? It's a choice between a universe where everything that can happen does happen across an infinity of branching realities versus a universe where, the future is fundamentally uncertain, governed by probabilities we may never fully grasp.
It really makes you think about the nature of reality, doesn't it? If you're in the many worlds camp, then your choices, every little decision you make is splitting off like whole universes.
Right.
Talk about pressure. But if you embrace this inherent randomness, then you have to accept that some things are simply beyond our control, beyond our ability to predict or fully understand.
Both perspectives have their allure and their challenges.
Yeah.
MWI is incredibly elegant in a mathematical framework.
Right.
But as we've seen, it comes with a lot of baggage, both scientific and philosophical.
Yeah.
Accepting fundamental randomness might seem less satisfying at first,
Right.
but it might be a more honest reflection of what we observe in the quantum world.
And you know what? Whether you're team many worlds or team randomness, it doesn't change the fact that quantum mechanics is one of the most fascinating and mind-bending areas of science out there.
Right.
It forces us to confront our assumptions about reality and to grapple with questions that have puzzled philosophers and scientists for centuries.
Absolutely. And I think that's what makes this deep dive so compelling. Your source material didn't just lay out the facts about MWI.
Right.
It went deeper, exploring the philosophical implications and the alternative perspectives.
Right.
It encouraged you to think critically and to question even the most seemingly uh, established ideas.
That's the beauty of a deep dive like this.
Yeah.
It's not about giving you all the answers. It's about giving you the tools and the information to form your own conclusions, to keep questioning and to keep exploring.
And to appreciate the sheer mystery and wonder of the universe we inhabit.
Yeah.
After all, we may never have all the answers.
Right.
But the journey of discovery is what makes it all so rewarding.
So to wrap things up, I just want to say that this deep dive into the many worlds interpretation has been an absolute whirlwind of mind-bending ideas and challenging concepts.
Yeah.
We've explored the probability puzzle, the philosophical objections, the alternative perspectives, and it's clear that this is a debate that will continue to rage on for years to come.
As it should. These are the kinds of questions that push the boundaries of human knowledge and inspire us to keep searching for deeper understanding.
And who knows, maybe someday through further research and experimentation, we'll finally unravel the mysteries of quantum mechanics and discover the true nature of reality.
Until then, the exploration continues.
Thanks for joining us on this incredible journey into the mind-boggling world of the many worlds interpretation. Remember, there's a whole universe of knowledge out there waiting to be discovered, so keep questioning, keep exploring, and we'll catch you on our next deep dive.